time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy, AFM Radio.
Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention those darn good friends of York University. I'll be one of your three hosts this evening. I am joined by the ever-ready Julie.
Hi.
And, of course, from the far reaches of the West, Satish.
Hi, everyone. I hope you guys are great.
Oh, we're always great. It's Monday. And because it is Monday, we are broadcasting live from the Alan I. Carswell Observatory at York University in Toronto, Ontario, Canada. And it is Astronomy Night in Canada. Oh, everybody should know that by now. We've been doing it for 10 years. Where the lineup is entirely Canadian, starting with ourselves, York Universe. On to Western world's quirks and quarks, not to mention science for the people. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That's Eastern Standard Time here in North America. Or Tuesday morning, 2 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi there, team. And it runs surprisingly from the hours of 9 till 10, coincidental with us, Eastern Standard Time here in Toronto. By all means, point your favorite web browser to observatory.info.yorku.ca and follow the links to the online public viewing session and click on the link to join the team. Of course, you can also pop across to YouTube and do a search for Alan I. Carswell Observatory, and you'll find the YouTube link there as well. Streaming live images from the 1 meter telescope. It is gorgeous outside tonight. For a change. It's really nice. I don't know what happened, but it's great. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments about past shows or suggestions for future topics, drop us a line, observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory. And on Facebook at the Alan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, see our website, observatory.info.yorku.ca, and hit the big friendly donate button. As I said, there is live imaging transmitted from the 1 meter telescope at the moment. Pop across there and have a look while you listen to us. So, Julie, Satish, it's the middle of December. It's our last show for the year, believe it or not.
I'm having a hard time figuring out where the last 12 months have gone.
That sums it up very well indeed. It's just gone by in a blur, not just astronomically speaking, but every type of speaking. What about you, Satish?
Sorry.
That's okay. I was just going to ask whether you'd seen anything interesting in the night sky other than light pollution in Vancouver.
No, that's a hard no, a big no, whatever the word is. And you can just double the blur twice, what Julie just said. I think I just finished the end of 2021, so yeah, that's my answer to your question.
Things have moved along, but astronomically speaking, there's been lots of interesting things, and so I'm going to recommend everybody stay tuned because each of us is going to give our favorite event, astronomically speaking, for 2021 about halfway through the show. However, before we get to that point, we've got a little bit of history to deal with. Julie, would you like to lead the way, please?
Sure thing. So we'll start with December 12th, 1961, and the launch of Discoverer 36, which was also known as Corona 9029.
Corona. Oh, really? No. I'm sorry. Excuse me.
Sorry.
You had to pick it up.
I'm going to go with not the virus. There's no way they knew about this back in 1961. And if they did, they should have done something. This was an American optical reconnaissance satellite. And on the same rocket that launched Discoverer 36 was another satellite called Oscar 1, which was the first amateur radio satellite. Discoverer 36 operated in low Earth orbit, took some images that were recorded onto 70 millimeter film, and that was returned in a satellite recovery vehicle 4 days after launch. And after that, the satellite remained in orbit until it decayed on March 8th of 1962. Oscar 1, as I said, was the first amateur radio satellite, and it carried only a simple beacon. For 3 weeks, it transmitted its Morse code message of HI, and to this day, many organizations identify their Morse transmitting satellites with HI, which also indicates laughter in the amateur telegraphy world. Oscar 1 lasted 22 days and ceased operations on January 3rd, 1962, and re-entered the atmosphere at the end of that month. Not only was it built by amateurs, it was only about 4 years after the launch of Sputnik 1, and amateurs had already built a satellite, so that's pretty cool. But it was also the world's first piggyback satellite and the world's first private non-government spacecraft.
Goes to show that the non-governmental agencies have been hard at work since almost the beginning of the space era. Amateurs of many differing varieties have continued to populate Earth orbit. We've got a solar sail in orbit at the moment that was launched by the Planetary Society. So there's a long and rich history here of, shall I say, the amateur involvement in space exploration.
Yeah, it's really cool. I had never heard of Oscar 1 before.
And I think I'm not certain, but I'm pretty sure that there has been follow-up Oscars as well.
I believe so, yeah. I think there were, I might be getting confused with my other history piece, but I think there were 2 or 3, maybe more. I'll look it up.
I don't think any of the three of us are actually ham radio operators, are we?
No.
Then we would know the answer. You're not a ham, are you, Satish?
I've not even seen one properly ever, except the occasional pics on the internet. So no.
Well,
pardon my ignorance, but I was just saying, what exactly is a piggyback satellite?
It's not the primary payload. So the vehicle is carrying one satellite, which is the paying customer or the principal paying customer, but there's room in the payload area for a secondary or a tertiary satellite that can be sort of tossed overboard on the way into the final orbit for the primary satellite.
Oh, that's pretty much it. Okay, I thought there was something really special to the word.
No, piggyback, of course, is just a long used expression for somebody jumping on somebody else's back and being carried around.
Yes, yeah.
There were 4 Oscar satellites, and then Australia got in on this, and there was an Australis Oscar 5.
There you go. I was quite sure that I'd heard of more than one Oscar, but so 1961 carrying on to probably relatively recently for that Oscar 5.
69 for Oscar 5.
Oh, only 69. Okay. Fair enough then. Okay, let me bring us a little further back in time, all the way back to 1546 and December 15th. I'm sorry, Satish, I'm actually taking your thunder here. This is a birthday shout-out to Tycho Brahe. And just for completeness, he passed away on the 24th of October, 1601, so at the young age of 55, although back in the Middle Ages, that wasn't a bad age. He was a Danish astronomer, but he was more than that. He was also a reputed astrologer, not to mention an alchemist. So back then you sort of were a jack of many trades, so as to speak. Without going into all sorts of detail with respect to his observation, suffice it to say that he was arguably the greatest of the pre-telescopic era observers. He delighted in compiling astronomical accuracy of objects' positions in the night sky. And this was really, really important for us to be able to follow those subtleties associated with things like precession and nutation and so on, things that, the ancient observers on our planet were able to figure out long before Tycho Brahe, long before the telescope. Subtle variations in the movement of our planet as it goes around the sun, measured over literally not just days, weeks, months, but thousands of years. Brahe was very, very good at his observations. And in fact, it was his observations of the planet Mars in particular, which eventually allowed Johannes Kepler to determine his 3 laws of planetary motion. So, as I said, his observational accuracy was absolutely phenomenal. He also observed a supernova in 1572, which further underscored the important notion that the universe was, in fact, changing, which was contrary to the Aristotelian view of the universe at that point in time. The universe was unchanging, yet here we had a new guest star in 1572, and with the lack of parallax, which Tycho Brahe determined, concluded it had to be a long way. He didn't know how far away, but it was certainly not an atmospheric phenomena, which is what changes in the night sky were often reported to have been, just something in the atmosphere, lightning or something along those lines. He was not a big fan of Kepler, though, just as a matter of interest. Kepler was a very straight-laced individual, very pious individual. I think it'd be fair to say that Brahe was far from that. We would call him a party boy in this day and age. He was rambunctious. He wasn't particularly thoughtful. He also engaged in a rather catastrophic duel in 1566 with his uncle, basically over who was the better mathematician. That's where Brahe lost the front of his nose, the bridge of his nose, which was replaced by a brass piece that he kept until his dying days in 1601. So, as I say, he wasn't exactly the most cultured of individuals, our Tycho Brahe. But putting aside his lack of etiquette, let us just be polite and say that, he was, astronomically speaking, a phenomenal observer. The fact that he was in good with the Danish king there for many a year certainly helped. He built terrific observatories from where he could observe in the relative peace and tranquility, and that, as I said, established a set of observations that was second to none in accuracy. So, Tycho Brahe, birthday shout-out, December 15th, 1546.
An astronomical astronomer. Sorry.
It's interesting. You wouldn't think that like a party person would be like, yes, and now let me go seclude myself with a telescope and take very accurate notes.
It's true. It really is true. When I first sort of started reading up, now this is many decades ago, about Brahe's life, it did seem incongruous. I mean, here he was spending long hours measuring with, as I said, phenomenal precision, the accuracy, the positions of objects in the night sky. And then when it was cloudy, I guess, Julie, he just went out and partied. I mean, I guess it was the two sides of the coin. If it was clear, he was diligent. If it wasn't clear, he was partying. He was partying.
Well, I guess as long as it was cloudy.
Yeah. But remember, he was up there in the Scandinavian corner of the world. So in the wintertime, those nights were very, very long. I guess in the summer they were very short. So perhaps it was a seasonal thing, partying in the summer and working in the winter. I don't know.
He's quite an inspiration for the current generation of budding astronomers studying in the university right now, because you can party and still be a good astronomer.
I certainly don't want to be the one who is suggesting that that's a good plan to all of my colleagues out there. It didn't come from me.
Yeah, I agree with you, Paul.
Just as well, I'm probably retiring. Yeah. Okay. Satish, I think you want to carry on with a little bit of history as well.
Yes, well, this is let's continue the shout-out party, the birthday shout-out party. Just a couple of days before, although quite a few years later, almost a century later. So December 13th, 1662. I want to give a birthday shout out to Francesco Bianchini. And the name is fantastic, of course. And he was an Italian philosopher and a scientist. Well, that was what Wikipedia says, although the reason we're talking about him here is because he was one of the reformers of the calendar of his times, which I don't even know what the calendar is actually or was. And then he was working for the Curia of the three popes at that time. He constructed a meridian line in the Basilica of Santa Maria degli Angeli e di Martiri. So whoever is listening to this and knows Italian, please excuse me. This was in Rome. So basically, he just constructed a meridian line for correcting the calendar then. He was also a fellow of the Royal Society of London as of January 1713. And then he deduced the rotational period of Venus using a 2.6-inch, 100-foot focal length aerial telescope, which I was hoping, Professor, if you would like to probably tell us more about, if that is worth it. His book, which he published sometime in his life, depicted Venus with an empty center. People also talk about his lack or his inclination towards the Copernican view of things in the universe. And he has craters on the moon and Mars named after him. So happy birthday, Francesco Bianchini.
I don't know what an aerial telescope is. I mean, 100-foot focal length, I mean, it sounds like it was the equivalent of a really long refracting telescope, because refractors really were the only telescopes of that era of consequence, although reflectors were becoming known courtesy of Newton. But a 100-foot focal length, wow.
I mean, sorry.
That gives great magnification. There's no question about that. But image of Venus so that you could see the differing phases.
Okay, I've Googled it.
Yes.
It's kind of cool. Okay, so imagine a telescope, cool. Right? Your two lenses, and instead of a tube between them, there's just a big gap.
Right. Okay.
And so like a string or something attaching the two.
Right, so that they could stay in good alignment. But obviously, in the age of no light pollution, you can get away with this because it's dark around you. Wow. Okay. Well, as I said, 100-foot focal length. That's a phenomenal level of magnification that you're going to generate.
So it really is as phenomenal as it sounds. Like it was a Huygens variety telescope, and that's what it says. But like I said, I wouldn't be deft enough to be able to get into the details on air. But okay.
Well, I mean, if you're trying to determine the rotational period of Venus, you've got to be able to look for sort of landmarks, if I can use that term, on Venus. Right. Now, back then, they weren't sure. They didn't know why Venus was so featureless. We now know, of course, it's completely cloud covered. But he would have been searching for features on the Venusian disk that would allow the rotation rate to be determined. I dare say he basically failed, but that wasn't because he didn't have good equipment. It was because Venus rotates on its axis incredibly slowly. And of course, you can only see the cloud cover anyway. So he was hard up against it, I'm afraid. But 100-foot focal length for a 2.6-inch lens generates a serious amount of magnification.
The interesting thing is, at this particular design probably was of interest to even Giovanni Cassini and Campani. Well, there's quite a few names who probably were using this around that century, if I could place it. The Paris Observatory and then Rome, of course. But yeah, I'll shut up.
Very neat. Very neat indeed. Okay, Julie, you want to bring us a little closer to modern era?
Sure, let's do it. We are fast forwarding to December 16th, 2001, and the Starshine 2 satellite being deployed by the STS-108 mission. So this was a U.S. high school educational microsatellite, which is cool. It was built with participation of 25,000 students in 26 countries. The satellite itself was a 0.5 meter wide sphere that was spinning, and it was studded with sunlight reflecting mirrors. And so from the ground, it was probably pretty interesting to see as it was flying overhead. It would, because it was spinning and had all those mirrors, would be flashing light passing overhead, pulsing as brightly as a first magnitude star. So it was it was brought to space on board Space Shuttle Endeavour. And released into Earth orbit for 5 months and re-entered the atmosphere in April of 2002. Project Starshine was a consortium of volunteers that were supported by the U.S. Naval Research Laboratory, the Space Grant Program, and NASA. And as I mentioned, involved school-age kids in this cutting-edge research. The mirrors dotting the satellite were actually ground by thousands of students. And the mission was to explore the outermost reaches of our atmosphere, the super thin layer of the atmosphere called the thermosphere, which is 1,012 times less dense than air at sea level and has many Earth orbiting satellites in it. The re-entry of Starshine helped to study how the thermosphere reacts to solar activity. If the thermosphere were steady, it would be easy to figure out decay rates for Earth orbiting spacecraft, and you could do that calculation. The drag caused by, there's still atmosphere there, so you get some aerodynamic friction or drag that's caused by the atmosphere, and it causes those low Earth orbit satellites and spacecraft to lose altitude. And Starshine 2 actually returned to Earth early. Its expected reentry or decomposition of its orbit was expected to be in June of 2002, but the sun was extra active during the first few months of 2002. That solar maximum was double peaked, which was unexpected, but actually great for this experiment. Kind of like serendipitous, lucky timing.
We won't even talk about Skylab and its early return to Earth in the 1970s. So yeah, there's no question. There's no question in the world that trying to predict atmospheric re-entry times is still as well. It's not a strong science. We can estimate, and we're getting better at it. But when the sun heats up our atmosphere and it expands, that throws a lot of calculations completely out the window. So better understanding the way the thermosphere responds to solar radiation really is an ongoing challenge to this very day. So this was a little bit ahead of its time as far as an experiment to try and understand the thermosphere is concerned. And it was led in large measure by, again, sort of like an amateur community.
Yeah, I always am interested in projects that involve like student generated experiments or student generated anything, really, student involvement. But I find it particularly interesting when it's like high school level, because I probably would have been all over that.
Yes, you would.
If I was still in high school in 2002, like, yes. It would have been like, I'll grind a mirror. I don't know how. Show me. Let's do it.
Let's hope your children have the same opportunity with their science teachers. I mean, yeah, when I go all the way back to my high school days, back in the Middle Ages. But it was really exciting to try and grind mirrors. We tried to build a radio interferometer at the school and so on and so forth, to have these experiments that would literally pick up information from space. This particular experiment was not just picking it up, it was sending something into space and then picking up information from space. I mean, how cool is that? Talk about exciting for a science, interested student.
I'd be interested to know, like, of those 25,000 students that were involved, like, what percentage of them were inspired by it to pursue careers, or maybe not even careers, but like, you know,
an
interest in like strong involvement in the amateur, you know, astronomy community or something like that.
Yep. Correct. I don't know how we would ever find that out, but I'd like to believe that a serious percentage, of that 25,000 have retained their keen interest in, science, at least, if not necessarily astronomy.
Yeah, something to be said about hands-on learning and like
absolutely
doing a thing rather than a worksheet.
Looking at the students who work in the observatory on campus, there is no doubt in the world that those who have been associated with the observatory have gone on to either do something in astronomy or have retained a keen interest in astronomical discoveries, astronomical activities, and so on. And that's almost to a person. So as you say, hands-on, no replacing it as far as an experience is concerned.
Very true.
Okay. Moving back a little bit in time, I remind you that Comet Halley, not Comet Leonard, Comet Halley came by in 1986. This is the 76-year period comet that swings in and around the sun as regular as clockwork. For those who are getting up tomorrow to watch the Geminids, have a look out for Comet Leonard, by the way. Before we lose it into the solar glare at sunrise. But in the 80s, everybody was getting excited about Comet Halley, yours truly included. So you would have thought that given our prowess, the world's prowess in creating satellites, that everybody and his dog would send a satellite to go and say hello to Comet Halley. Well, if you thought that, you'd be wrong, because NASA didn't. However, the Russians, or more to the point, the Soviets, certainly did. The launch of Vega 1 on December 15th, 1984, and just as a footnote, Vega 2 launched on December 21, 1984, these two spacecraft headed out to intercept Comet Halley in March of 1986. And it was part of an international flotilla of spacecraft and nations that went out to have a good close look at Comet Halley. The Japanese sent a couple of spacecraft, as I've just said. The Russians, the Soviets, sent a couple of spacecraft. The European Space Agency sent a spacecraft. NASA had a couple of spacecraft in the solar system doing different things, and they graciously turned them around so that they could have a look at Comet Halley, but they did not actually launch a dedicated mission. To this day, it strikes me as a missed opportunity. Anyway. End of political commentary. Vega, by the way, stands for Venus and Halley in Russian, in case you're going, but it's a GA. Yeah, well, I know. It's the Russian word for Halley apparently starts with a GA. Anyway, so Vega has that dual purpose, and the mission intercepted both Venus, the planet Venus, courtesy of the Venera probes, because, of course, the Soviets have been very good at going to Venus. And then after flipping by Venus, they used Venus with a gravity redirect to intercept Halley. So we're talking about a vehicle that, Vega was a vehicle that was in essence a Venera probe that was modified. It carried with it a lander, which is what all Veneras did. It also carried with it a balloon, an airborne balloon package to wander around the atmosphere of Venus, and then to go on after it had done its bit at Venus onto Comet Halley. It flew by, this is Vega 1, flew by Venus on the 11th of June, 1985. So that was, only about 6 months after launch. Passed Venus at a distance of about 39,000 kilometers. As I indicated, it had a balloon experiment. So they basically dropped it into the atmosphere, and then the balloon deployed at an altitude of about 54 kilometers. Well, it ended up at 54 kilometers. The deploy sequence was a little more involved than that, but the balloon ended up cruising for about 24 hours at an altitude of about 54 kilometers, carried around on the atmosphere by The winds on Venus moved about 11,000 kilometers in that 24 hours, so it was really beetling along. Pretty darn good. And the balloon experiment was actually chock full of data. They sent back lots and lots of good data. The lander did make it to the ground successfully, but it had a bit of a rough ride on the way down, and really they didn't get very much data from the lander. It survived on the ground for about 56 minutes, which on Venus is pretty darn good, actually. So very, very successful Venus encounter. Gravitational assist, it redirected onto Comet Halley, and it flew by Comet Halley on March 6th of 1986 from a distance of about 9,000 kilometers. Very, very intense few hours during closest approach. Hundreds of images of the nucleus of Comet Halley. Some of them were pretty good. The nucleus of Halley is about 14, 15 kilometers in length. It looks like a misshapen potato with a couple of really bright jets and a really, really dark surface. And this was confirmed by the European Giotto spacecraft that basically flew in the wake of the Vega spacecraft. The spacecraft continued to operate until around about January 30th of 1987, so nearly another year or thereabouts, although it didn't do too much after that, although it did pass through a couple of cometary tails, so it did do a little bit more analysis of the interplanetary medium. Whichever way you want to cut it, the Vega 1 and the Vega 2 missions were incredibly successful, and as I said, part of this international flotilla minus NASA, that intercepted Comet Halley in 1986. And as a small footnote, 2061 is the next return of Comet Halley, and so by the time we get to 2024, we will be halfway there. Yes, halfway there from the last apparition to the next one.
2061, you say?
You'll still be here, Satish. Okay, I want you to send notes, photographs. Okay, I'm not quite sure where I will be and how reachable I will be, but that's besides the point.
Okay, that's sure, of course, yes.
That's the right answer. That is the right answer.
2061. Yeah, I might still be around then too.
You will be, my dear. You're so young. Come on, absolutely.
I do come from good stock.
There you go.
Great grandparents and grandparents that, lasted. So
2061, the flyby of Halley should be much better than it was in 1986. It didn't get particularly close to Earth, and as a consequence, it really disappointed a lot of observers, particularly those of us in the Northern Hemisphere. It was higher in the Southern Hemisphere skies, but it wasn't a particularly good engagement in 1986, much better in 1910, and 2061 is meant to be much better as well. So you've got a good show coming up, folks.
You sure do.
Yeah. Satish, finish us off, please.
Sure. I still haven't learned how to pronounce this word, but we're still talking about Venus, or Venus. Is it Mariner 2 or Mariner 2?
Mariner.
Okay, I'll go with Mariner.
As in the ancient Mariner.
The ancient Mariner, okay. So, people, December 14th, 1962 was the year when Mariner 2 did its flyby of Venus, which was the first successful Venusian flyby by NASA launched space probe to get the facts correct. While it was going towards the planet, it measured solar wind, and it confirmed Luna 1's measurements back from 1959. It also measured interplanetary dust, proving a rather scarce presence of the same than what was expected. So people expected more dust. There's not so much dust. We're working hard, of course, to make it happen because we have so many satellites now, which, of course, is not part of the interplanetary space. But anyways, also, it detected solar flares and cosmic rays from outside the solar system. And it revealed during the flyby that Venus has cool clouds. That's as cool as a definition can get. So Venus has cool clouds and an extremely hot surface. This is probably why the Venusian nature stuck in popular culture after that. Maybe it was so before that as well. Also, December 14th, quick birthday shout out to Mr. Steve McLean. He was born in 1954 on the same day. He's a Canadian astronaut, which I'm pretty sure most of us listening, like most of you listening, know him, probably even personally. So this person is a York University alumni. He finished his doctorate from here, and he is an honorary fellow of the Bethune College, Professor.
Yep,
And
he
he's
is.
also president of the Mont Megantic Observatory project, which I have no idea of. Embarrassing. And then he also served as a mission specialist on STS-115, one of the many STS missions that I will never learn to understand. And then he was also the first Canadian to operate the Canadarm2 and the second Canadian to perform an extravehicular act, something like that, after Mr. Chris Hadfield. So,
activity.
Sorry, yeah. Well, the same thing.
Yeah, close.
Sorry.
It's quite true. Yes, Steve did complete his PhD in the Department of Physics and Astronomy there in the 80s. So a very proud alum of York University. But Venus, proud alum of York University. But Venus, in the early 60s had lots of surprises. Mariner 2, as you indicated, revealing relatively cool clouds. In fact, going back to the Vega balloon experiment that I mentioned slightly earlier, at a height of 54 kilometers, the cloud temperatures that that the space probe was subjected to, it's basically the sort of temperatures that you and I experience here in the summer in Ontario, sort of around about 30 Celsius. So as you get higher in the cloud deck of Venus, the temperature subsides. Of course, on the surface, 750 degrees Kelvin, about 400 degrees, 450 degrees actually, Celsius is very, very hot. So a little bit of a surprise environment. And that's why, of course, it is so darned hard for any spacecraft to survive on the surface, between the incredible heat, the very significant atmospheric pressure, and then you toss in a little bit of raining sulfuric acid. It's a tough environment to survive on the surface.
You said tough.
Tough, very hard to survive.
Lots of interesting ways to die.
Yes, exactly. Hades, so as to speak. Folks, you've been listening to Satish, Julie, and myself talk about This Week in Space and Astronomy History. By all means, point your favorite web browser to observatory.info.yorku.ca and follow the links to OPV, online public viewing. Live images from the 1 meter telescope are on tap at this point in time. So a big shout out to the observatory team. Couple of quick yes, indeed. We will not be back until January 10. We're shutting down, so as to speak, because the university is shutting down over the Christmas break. And so tonight will be our last live show. Of course, the AFM crowd will rack up some of the latest and greatest shows so that there will still be good entertainment for you on Monday nights, but no live shows again until January 10. The other thing is, after our show tonight, you should rush outside if it's clear, because the Geminid meteor shower peaks tonight, around about 2-3 o'clock tomorrow morning. This is one of the more reliable of the meteor showers, so it is highly likely that we will pick up 60 to 100 meteor sightings per hour in and around the early hours of tomorrow morning. If you are clear of the city, if you're in a light polluted environment, okay, cut that number probably in half, if not further. But this is a meteor display that is not produced by a comet, but rather is produced by an asteroid. 3200 Phaethon is what is spewing out material into its orbit, and that, of course, debris is what the Earth passes through every year, regular as clockwork. So tomorrow morning, 2-3 o'clock, the moon will be a little on the bright side, but it will be setting shortly after that, and so therefore that will improve the likelihood of you being able to see a good meteor show. Anybody getting up to watch that tomorrow morning?
I am hoping to be able to get up. That's the first thing. That's the most important thing. And
what time?
I think it's 3 in the morning. I should get up and then probably walk over to the beach by the time it's 4:30 max, is what I'm assuming.
Yes, absolutely. And if you've got a good clear view of the western horizon, west-southwest is where you want to be looking for the radiant, because as the name suggests, it's coming out of the constellation of Gemini.
But pardon me for interrupting, sir. That is the problem, the clear sky thing. Well, we have clouds today and tomorrow as well. I will still try because I want to make sure that people know that at least once in my life I got up so early and I tried.
I know Vancouver is renowned for its lack of clear skies. Cloudy from July 1st to June 30th. We often quip. It's not quite that bad, but still.
Wow.
Okay, so before we get to the news items, folks, I'd like each of us to cite the one astronomical event or space science event that happened this year that really sort of sticks out for you for whatever reason, okay? And Satish, why don't you go first, because I see you've actually given us the link here. What was the event for 2021 from your perspective?
Well, actually, so now that you say it that way, like it's not exactly an event, it's a discovery of sorts, but it's still an event in the astronomy world.
Mm-hmm.
So we or NASA people, via the Chandra X-ray Observatory, they have been able to find an extragalactic planet not far away, right next door, like our neighbor, Mr. M51. Is that a neighbor? Sorry,
Messier 51.
Yes. Okay. So one of our neighbors actually, and then that's it's like it says it's about 28 million light years away from the Earth, and it is a system with a sun-like star, and that is also in orbit around a neutron star or a black hole. So unless I'm confusing or mixing of facts, I think it's the same black hole which also probably falls into the intermediate mass black holes. And of course, we discovered a planet. So those are actually two discoveries which really stuck out. And the only dumb question I have is why were we not looking at that portion of the sky earlier than today? Of course, that simply means that the light never reached us till now. But
well, to be able to actually make the sort of detailed observations required to see an exoplanetary signature in a distant galaxy is not easy, is the short answer. And as I recall in this particular observation, while they are confident, the orbital period of the planet in question, I think, was a number of years, in fact, if not a couple of decades. And so the confirmation observations will be a little slow in coming. But as I say, looking at extragalactic exoplanets is not easy. But the sheer fact that we now believe we have one on the books just shows you that, the planets that we're finding in our own galaxy is not unique, that other galaxies do have exoplanets, which, of course, is what everybody expects.
Right. So, and I think I might be mixing the news from M31's black hole with this. But like I said, there have been a couple of similar discoveries, like interesting discoveries, not similar, but. So.
Black holes are always up there, of course. Yes.
Yes.
Julie, your observation or event?
Mine's an observation. I actually set an alarm and got up in the wee hours of November 19th and put on something warm and made my way downstairs. I was just getting a coat on when I heard the stairs creaking behind me. I was like, who's there? And it was my daughter, who's 12, and she was like, what are you doing? I'm like, I'm going outside to look at an eclipse. You coming with me? She said, sure. So it was nice to have my daughter join me for
daughter.
Yeah, for that observation. It is rare that I'll often set an alarm, open an eye, look out the window, think about the temperature forecast, and go, nah. But I was happy. I got up and did that, despite the fact that, I had to get to work that day.
I remember when you wouldn't hesitate to be up in the dome in the observatory to all hours of the night, freezing there with your colleagues. Yeah,
that was 20 years ago.
Well, I'm glad you're leading your daughter down the correct pathway to show her the wonders of the night sky, even at 4:00 in the morning.
Yeah, and it was nice. The Space Place Canada had an event the evening before where Randy Atwood gave a talk about the eclipse, and then we had a tour led by I'm terrible, I've forgotten his name, but we had a tour of the Trottier Observatory at Simon Fraser.
Yeah,
that is an amazing observatory.
It is indeed. It is indeed. So this particular lunar eclipse was the one last month in November, correct?
Yes, it was the one last month in November.
Right. Okay. Very good. And so you saw, so the clouds stayed away well enough for you to be able to see the sort of the orangey glow with a little bit of a snippet there at the South Pole where the Earth's shadow didn't quite reach?
Yeah, it was, I mean, the forecast had called for snow. I was like, oh, that bodes well. And it was completely clear. There was no snow. I was glad I didn't go, well, whatever, 100% chance of snow, that I actually set the alarm and went off. And by the way, I believe that if you would like to see the tour of the observatory, it is on the Space Place Canada YouTube channel.
Excellent. Excellent. My particular event is the coming of age, or at least what I'm going to interpret as the coming of age of space tourism. July 11th of this year, and the flight of Virgin Galactic VSS Unity. That was the flight. It had Richard Branson on board. Not that that phases me one way or the other, but there were a total of 6 folks who flew to the edge of space to 85, 90 kilometers above the surface of the Earth, experienced weightlessness, came back, landed at an airport, the whole 9 yards. It was a delightful experience to watch because, of course, these things are being transmitted. Very shortly after the Virgin Galactic flight, of course, it was Blue Origin, Jeff Bezos flying up to the Kármán line, just a touch higher than Virgin Galactic. And since that point in time, we've had 2 more flights of Virgin Galactic. We've had 2 more flights of Blue Origin, and we've had the Inspiration 4 flight from SpaceX that took 4 amateur astronauts into Earth orbit for, give or take a bit, 3 days. So since July of this year, there has been, almost a parade of regular individuals. Perhaps that's a slight exaggeration because, of course, the tickets associated with all these flights is in the hundreds of thousands of dollars, or in the case of SpaceX, into the tens of millions. So it's not something that just you, Julie, Satish, myself can jump on and go into Earth orbit or even do suborbital. But the sheer fact that everyday citizens now have the opportunity to do this really is important. In contrast to the early part of the decade, the early part of the century, where we were flying space tourists to the International Space Station. I think there were 8 or 9 of them that flew all told to ISS. That was a very different arrangement. There, you really had to be a part, you had to fly up with the Soyuz spacecraft and so on and so forth. Now, there are 3 private entrepreneurial ventures that can take you either to the edge of space or into Earth orbit. Truly, the era of space tourism, in my mind, has arrived. We've been expecting it for a long time. It came of age in 2021, and I will pinpoint the date as July 11th with the flight of VSS Unity, the Virgin Galactic flight to the edge of space. I was delighted to see it happen this year, and we're going to watch it unfold with increasing frequency in the coming years. And of course, there are other groups that are talking about, hot air balloon rides to the edge of space where you can drift for hours, not just minutes, but drift for hours watching the curve of the Earth. You won't have weightless experience, but you will get phenomenal views. And they're now talking about private space stations in Earth orbit by 2030. So it has changed the landscape.
It sounds more interesting when you actually talk about it. You talk about it.
Well, if somebody offered me a ticket, Satish, I would be there in a heartbeat. But it's not going to happen. But I can live vicariously through all of these folks. The latest one was this last Saturday. Laura Shepard Churchley, the eldest daughter of Alan Shepard, the first U.S. Citizen to the edge of space with his suborbital flight in May of '61. His daughter followed in a far more comfortable manner some 60 years later, flying to the edge of space. I think that's just fabulous. I really do.
I got to see William Shatner at Fan Expo at the end of October, and he went on in great detail about his time in space. It seems to have really struck him.
That's what it looked like on the ground after the flight.
Yeah.
He seemed to be very moved by it. So I'm glad to hear that wasn't just for the cameras, shall we say.
No, I don't think so.
Great stuff.
It was interesting to see him talk about it. Mm-hmm.
Julie, James Webb, give us the rundown.
Webb.
Yes.
I hope I'm not jinxing anything with this story. Touch all the wood. All right, so the James Webb Telescope has been fully fueled up. Woot woot. So the JWST finally arrived safely at Europe's spaceport in Kourou, French Guiana, last October on the 12th, and the unboxing began and the prep to get it into the capsule to put it on the rocket began. Finally, because there have been many years of delays and cost overruns, but the current launch date is set for December 22nd, which is so soon. So during preparations for the launch, I think the last launch date before this one was supposed to be Halloween, if I'm not mistaken.
Correct.
And they were in the process of hoisting it into the capsule when a clamp band suddenly released, and it sent vibrations throughout the facility, throughout the telescope. And so the crews had to investigate what the source of the problem was, and now has been taken care of, hopefully. So crews finished fueling the thrusters in preparation for the launch. The thrusters made course corrections after it's separated from the rocket in orbit and maintaining its prescribed orbit and repointing the observatory during operations. The fueling process is dangerous, it's extensive, and it takes a great deal of setup and preparation. So it takes 10 days. The fueling happened between November 23rd and December 3rd. So there's lots of equipment and connections that have to be set up in advance. There's safety protocols that have to be followed to the letter. The fuel is hydrazine fuel and dinitrogen tetroxide oxidizer. These are extremely toxic. So the specialists have to wear like the self-contained atmospheric protective ensemble suits. That seems redundant, ensemble and suit. Anyways. And so once that fueling is done, then they could move into combined operations, which is when the teams that are working to prep the telescope and the teams that are working to prep the rocket come together and bring the two together. And so it was ready to be hoisted into place. This was when that incident occurred, so hopefully this time it goes well, and that the launch happens on time next week, right? The 22nd?
Yes,
yeah, so that's next week.
9 days. Not that anybody's counting.
You're saying this Christmas will be different.
Maybe.
All I want for Christmas is my JWST. Yeah,
as many of you probably know, because there's been so much hype around this telescope, it will be the largest, most powerful telescope ever launched into space. It's an international collaboration between NASA, ESA, and the Canadian Space Agency. It's going to be used to, it's going to use its advanced infrared imaging capability, stereographs, and a coronagraph to observe unseen and poorly understood aspects of the universe, including conducting a census of cooler objects in the universe like red dwarfs, brown dwarfs, etc., and circumstellar disks, which give rise to planets. It's going to observe smaller rocky planets that orbit closer to their stars, helping make a more complete census of exoplanets. And it's going to capture light from the first stars and galaxies to help us study how they have evolved. And another telescope news, it was announced on December 6th that the Hubble Space Telescope is once again fully functional. So yay, telescopes.
It's been a good month, it appears, for telescopes. Let's hope that continues, shall we say.
Touching all the wood.
Yeah, the JWST, there've already been books written about it because they started theorizing about JWST literally as Hubble was launching. So this has been a 30-year project in the making. It started its funding envelope in the late 90s. The original date for launch, as silly as this sounds in hindsight, they fully expected to be able to launch JWST in 2007. Yep, 14 years ago. You know, if I operated on that schedule with overruns and, you know, I don't think the university would have been particularly happy. Oh, we're going to give that exam next week, and 14 years later we finally get around to it. I mean, you know, yeah, it's really beyond belief. Yes, they well and truly underestimated the complexity of the undertaking. Because this is going out 1.5 million kilometers out to L2, it's got to be perfect. And so they've had to build a lot more testing into the process. But seriously, people, 14 years of overruns and a factor of 5 cost overruns. I mean, 1 to 2 billion is what they were expecting. It's now 10 billion. Yeah, the accounting leaves lots to be desired. Put all that aside.
Inflation.
Oh, right. Yeah. Okay.
Sorry.
Fine. We'll build that into.
You really want a sarcastic comment? You can let me know.
However, it will be a phenomenal astronomical instrument. I mean, we call Hubble astronomy's discovery machine. I'm waiting to figure out what we can call JWST, because if it lives up to potential, and I fully expect it will be absolutely wondrous what it's able to deliver in terms of data about the early universe, about exoplanetary atmospheres, about a whole host of things. So, yeah, we wait in great anticipation for December 22. And we'll wonder and worry about the next 30 days as it unfurls itself out of the the nose cone. Oh, wow. Fingers crossed. Go JWST. Let me give a quick summary about a rather interesting exoplanet that crossed my desk today. B, as in lowercase, Centauri, lowercase b, B Centauri b. It's symmetrical, people. Yes, I realize that. This is a star in the southern constellation of Centaurus. Not a surprise there. It's about 325 light years away from Earth. Interestingly, this binary star contains a B3 main sequence star and a close companion that we're still trying to figure out what the heck it is. But between those two stars, it's got a mass of between 6 and 10 solar masses. The B star is about 6 solar masses. We're guessing that the companion is 2, 3, or 4 solar masses. Still trying to figure that out. It's not the stars that are the big story, however. It's the exoplanet that is in orbit around that star. It was visually detected in 2000. Everybody thought it was an artifact of the imaging. They had another look at it in 2019, concluded, we should look at this again. And they did in 2021 and concluded it was a Jupiter, a very large Jupiter-sized planet, 10 times the mass of Jupiter, orbiting at a distance 550 times distance the Earth is from the Sun, 550 AU. That's well over 10 times the distance Pluto is from our Sun. So this is a long way out. The story, however, is that it shouldn't really even exist, because B-type stars have a tendency of ionizing and causing chaos in the circumstellar disk from which planets form. And so the sort of going wisdom was you can't form planets around hot stars. Well, guess what? We found one. So we're sort of quickly evaluating the whole situation. A really interesting find, a large planet a long way out from its parent star around a really massive star. On that note, you've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Alan I. Carswell Observatory here at York University in Toronto, Ontario, Canada. Our last live broadcast for the year. On behalf of the entire observatory team who's been giving great images, we wish you the best of the Christmas season, and we will see you in 2022. Good night.